Hello everyone, I'm really excited to be at the Platform Con 25 this year and to share with you a part of our platform engineering journey at Sodexo. My name is Hamed, and over the past 12 years, I've been working as software engineer, data engineer, and AI cloud architect across different industries. Currently, I'm senior platform engineering manager at Sodexo, and today I want to share with you the journey of the developer platform that my team and I are building to help us deliver data and AI products faster. Before diving into the platform itself, let me quickly introduce the context in which we are operating. Sodexo is the global leader in sustainable food and valued experience at every moment in life. We are present in 45 countries with 400,000 employees serving more than 80 million consumers every day in schools, offices, hospitals, stadiums, and many more. We are managing everything from food services to facility management, and all this in a decentralized model with group teams, regional teams, and on-site teams. As you can imagine, across all these services, data is everywhere. And to turn that data into real value, we are relying more and more on AI technologies. Data and AI are allowing us to adapt to many aspects of our business and to identify new opportunities for growth. It goes, for example, from anticipating the needs of staff by predicting the frequentation of our restaurants, guaranteeing a fair price by combining multiple datasets, or ensuring the right supply chain, or, for example, understanding the preferences of our consumers. All these missions are in the heart of the digital and AI factory. In this team, we are using data, AI, and digital technologies to build some products for our clients and our consumers. These products are built by squads composed of data engineers, machine learning engineers, data analysts, full stack developers, and many more. However, building so many products at scale inside a big organization like Sodexo is not quite straightforward. It is exciting, but it also brings a lot of challenges for our developers. Let's cover these challenges. The first challenge that our developers were facing is about the time that they were spending into repetitive manual tasks. Actually, things like setting up the environment, configuring some tools, deploying manually the code to the target environment, or writing some basic boilerplate code can take a lot of time when combined together. Without enforcing automation everywhere, the developers were losing a lot of time in such kind of tasks, preventing them to focus on what really matters, which is innovation and product features. So in many teams, up to 20 to 30% of the time were losing into this kind of tasks. Just imagine, for a team of 4 developers, this can represent up to 125 hours lost every month. Next challenge that our developers were facing is about the infrastructure complexity. Actually, most of our use cases are relying on Azure services such as Azure Machine Learning Service, AMLS, Azure Databricks, or Azure Container Apps. These services are great, but they come with their own specific API and SDKs that the developers must know and master to be able to fit the requirement that is expected. For example, for a machine learning engineer, when he wants to set up a model endpoint in Azure Machine Learning Service, he would have to learn and deal with the Azure ML Python SDK. The same way, when a data engineer needs to automate the deployment of his data transformation pipeline in Databricks, he would also have to learn and deal with the Databricks CLI or the workflow API that is exposed by Databricks for the automation. So all this brings some complexity for developers. And we understood that without defining some golden path and some abstraction on top of that complexity, it would be very complicated to scale in terms of products, right? Finally, one of the last challenges that we were facing is about quality at scale. When you start to have many products built in parallel by different squads, it becomes difficult to maintain the same level of quality everywhere. It could lead to inconsistency between different products, and it could also increase the technical depth in some of them. This technical depth can lead to a drop of up to 25% of the productivity of developers. So you definitely want to avoid that. All these are the challenges that guided us to create and build our internal developer platform. We decided to build that platform ourselves, tailored specifically to our needs and the needs of our developers. We knew we couldn't just use something out of the box. It had to fit our context, our workflows, and our ambitions. So at the heart of the platform, there's a clear mission composed of 3 elements. First, accelerate the product delivery by enforcing automation everywhere. Secondly, abstract the complexity of the infrastructure so that the developers can focus on real development tasks. And finally, enforce quality so that we can easily scale across multiple products without compromising on the quality. As we are building the platform, we also kept in mind three principles. The first principle is to treat the platform as a product, with a user-centric design, relying on some customer discovery workshop to understand the pain point from developers and trying to build a platform based on those feedbacks. The platform is also built based on some metrics, some real metrics to track the coverage, the adoption, and the satisfaction from end users. This is helping us to continuously improve it as an own product. Second principle is to propose, not to force, and this is quite important. We don't want to make it mandatory for all the developers to follow the single path defined in the platform. The platform is here to provide the fastest and safest path for building, but the teams can still innovate as long as they are compliant with the standards. And most often, this innovation comes back to be defined as a new path in the platform again for other developers. And last principle is to keep it open and collaborative. The platform is maintained by a team of platform engineers, but we strongly encourage external contribution from developers themselves. This contribution can be feedbacks or direct commit to the source code of our assets, and it is helping the platform to remain a living ecosystem where developers can also contribute. Well, these are the visions and principles that shape everything in the platform. So let's see now what's inside. Now that we have covered the why behind the platform, let's quickly go through the big picture of the platform itself. In this slide, we can see the different assets that are provided by the platform. First, we are providing some code templates. These are pieces of code that the developers can use to bootstrap new repositories quickly. We also have Dev Toolbox, which are a set of scripts provided into a custom CLI, command line interface, that the developers can use to achieve some common tasks like deployment, for example. Next thing is reusable modules. Actually, these are pieces of code that we have packaged into a library, a custom SDK, which is versioned and delivered to the developers, and they are able to use that for common tasks. We will talk about that one as well later. And finally, a portal, which is accessible by all the developers to introduce them on those different components that I just talked about, and to also enforce documentation and reporting. The platform is also built in compliance with a set of internal standards. The first is about engineering standards. This is actually some standards that are defined internally at the level of the team and defining the best practices in terms of software engineering, DevOps, machine learning engineering, or data engineering, for example. We also have some security standards and cloud standards defined at the level of the organization, which is helping to ensure consistency, quality, and security across all our products. Now that we have talked about the big picture, let's deep dive into how these different components of the platform are supporting the developer at each stage of their project. And to do that, we will start by the first phase, project initialization. This is happening every time the developers are starting a new project, right? So instead of starting from scratch, the platform is providing them with some code templates that they can use to quickly set up the repository by following the best practices already integrated into the template. The developers can use that in a self-service mode to generate their repository in a few clicks, just in a few seconds. This template is built using the Python cookie cutters tool. Next thing is environment configuration. Traditionally, the developer would spend a lot of time configuring manually the run environment for things like data access, pipeline orchestration, or model hosting. Instead of that, our platform simplifies this process by using a configuration-based setup. What does this mean? Now, the developer will only need to write some simple JSON configuration files to describe which dataset they want to connect to or how the step of their pipeline will have to be orchestrated together. And the platform will automatically take care of interacting with the right Azure service using the right API or the right SDK or the right CLI to be able to enforce that configuration into the Azure platform. So the developer will not have to learn again those API and so on because he only needs to rely on simple configuration file. To be able to manage that, we have implemented an in-house SDK that provides a unified configuration model and that is able to interact with the right Azure service. Finally, automation is key when you are starting a new project. So to achieve that, the platform also provides some pipeline templates that are in a self-service mode. Developers can also use that and automatically connect to these pipeline templates directly from their CI/CD to enforce, to integrate with some different tools, or to, for example, to enforce some continuous deployment workflows from day zero. Now let's move to second phase, iterative development. Once the project is initialized, it's now all about iteration and continuously developing. During this stage, the platform also provides a few things. First, reusable code modules. These modules are packaged into a library, a version library that is exposed to the developers, and they can use that to do some common tasks like logging, parallel execution, emailing, notifications, and so on. It means that for this kind of task, the developer will not have to reinvent the wheel every time. Instead of that, they can simply install that library as part of their dependencies, import the class in their source code, and just directly call the proper method to achieve those common tasks. Next thing is deployment simplification. Automating the deployment of code to target environment like Azure Machine Learning or Azure Databricks is not something that is straightforward because it requires a deep knowledge of these services. So our platform is simplifying this by providing a simple to use command line interface built in-house using the Python Click framework and allowing the developers to deploy their codes themselves by just running one single command. Inside that CLI, we are handling the connection with the Azure service and the specificities of that target environment. And finally, debugging and troubleshooting. Development is not only about writing code, right? Sometimes it's also about spending hours and hours investigating issues and bugs. To help on that, the platform is providing debugging and profiling tools to help replicating locally the issue that happens on Azure Cloud, or for example, figure out directly what went wrong into that cloud environment. Now let's talk about enforcing quality and standards. One of the ways we ensure this is through code quality checks. Our platform is providing a set of predefined quality checks that are automatically run against the source code before it is getting merged by integrating them in the CI/CDs of the project. These checks include some static analysis linters, security vulnerability scan, code complexity checks, and many more. It leverages some Python frameworks like ISOP, Black, Radon, Bandit, Megalinter, and many others. These checks are ensuring that the code is respecting the coding standards and allowing to catch some potential issues early in the integration phase. Next, we also have documentation generation. We all know how important it is to keep documentation up to date. With our platform, we have automated this process by generating the documentation directly from the source code itself and from the markdown files that the developer have written into his repository. So this is helping to keep the documentation version in the same repository than the source code and to automatically generate the HTML file from that source code and deploy it into a developer portal so that it is accessible by all the different developers. To do that, we are leveraging some frameworks such as Sphinx, MKDocs, or JupyterBook. Finally, we are also focusing on logging and monitoring. The platform ensures that all the logs and the metrics of the applications are consistent between the different products and centralized in Azure Log Analytics. This is enabling the site reliability engineers to monitor the state of the application and have a 360 vision on everything happening on the application using a Grafana stack for monitoring and alerting. To conclude, let's take a step back and look at how the platform has actually impacted our use cases and contributed to scale our products. First, the platform has been a game changer in enabling the teams to deliver faster without compromising on quality. By automating repetitive tasks, offering reusable components, or providing deployment tools, for example, we have significantly minimized the time that we were spending for development while ensuring that the quality remains at the core of every product that we are building. Second, the platform is also enforcing better collaboration across the different teams. By centralizing key components, tools, and best practices, the teams can now collaborate while working continuously on their project. And because all of them will be working in the same technical stack. Finally, the platform is also a solid foundation for our growth. As we expand in new areas, both functionally and also regionally, the platform ensures that we are integrating new product, tools, technologies, and frameworks without some friction and allowing some teams to quickly start new projects without reinventing the wheel every time. In short, I can say that the platform has been an enabler for faster delivery, better collaboration, and growth across different data and AI products. Thank you for your time and attention today. I hope you have gained some insight by discovering our developer platform built here at Sodexo, and I hope this will be valuable for you in your platform engineering journey as well.